podcast, Aviation Responding to its Carbon Footprint, with Mr. Alexis Leclerc, CEO of Leclerc Consulting. Hello, Mr. Leclerc.
Hello.
Could you tell us about the impact of aviation on our environment?
Of course, this industry is currently responsible for 2.4% of global CO2 emissions. According to the NGO International Council on Clean Transportation, the race is on. Aircraft manufacturers are all on their drawing board to find 1,001 ways to reduce the carbon footprint of their aircraft. While the hydrogen plane takes off slowly, others are working on a 100% electric plane. Commercial aviation has set itself the goal of decarbonizing the industry by 2050. Flying without increasing your carbon footprint is a goal within reach. Airbus and Embraer are working hard to get the first passengers on board in 2035. Teams of system engineers from Airbus are currently working on a propulsion system capable of converting liquid hydrogen into electricity and running an engine and much less polluting than current engines. The heart of the system consists of hydrogen fuel cells. By 2026, Airbus, in cooperation with the engine manufacturer CFM International, intends to install on the Airbus A380 its prototype propulsion system, which could be either a fuel cell supplying an electric motor or a gas turbine converting hydrogen instead of kerosene. Its use in commercial aviation still poses many technical challenges. In particular, the need to store this gas at very low temperature, minus 235 degrees Celsius, on high pressure in spherical tanks. In addition, hydrogen would put a strain on mechanical parts as it burns at much higher temperature, another challenge for a sector subject to drastic certification and security rules. Fuel cells emit only water when they turn hydrogen into electricity, but the power of the propeller motors, the power is limited. A gas turbine fueled by hydrogen is more powerful. It is also more polluting because the combustion of hydrogen emits nitrogen oxides, which contribute to climate change. Both technologies are being evaluated to determine their potential for aviation, and a choice would be made based on the results. Airbus plans to test the system in the air from 2026 to 2028 under real flight condition. Once the technology is chosen, Airbus would launch in 2028 the design of a real hydrogen plane with 100 passengers and a range of around 2,000 kilometers, characteristic that the company engineers consider realistic with current technology. If all goes according to the plan, Airbus' first hydrogen-powered plane should enter into service by 2035. Brazilian manufacturer Embraer also plans to launch its first hydrogen plane in 2035, according to what the company revealed this week. That these would be smaller, with 19 to 30 seats and a more limited range, around 370 kilometers. Boeing has also invested in hydrogen. It's a small two-seater demonstrator flew for the first time in 2008. For now, however, the American company has still not announced any aircraft, instead focusing on sustainable aviation fuel, better known by the English acronym SAF, Sustainable Aviation Fuels, to reduce emissions. The synthetic fuels, which are also part of the decarbonization strategy for the manufacturers, can be produced, for example, from used cooking oils or CO2 emitted by factories. The CO2 is captured at the source in industrial chimneys and chemically recombined with energy from hydrogen to become a fuel again. For its part, Safran is seeking to establish itself as the centerpiece of carbon-free aeronautics. To do this, the equipment manufacturer had chosen to join forces with several business units at Thales. Strategic takeovers that will enable it to assert its leading position, particularly in the energy performance segment for civil aviation, but also as a supplier of high-tech systems for military craft. The company was best known for its participation in the energy saving induced by improving the energy efficiency of its reactors. It is largely to him that we owe the fact that the plane today consumes just over 2 liters per kilometer per passenger. or as much as an average car with 4 people on board. But Safran's strategy goes further than engine progress. Now the equipment manufacturer is working to reduce the weight of aircraft by replacing physical equipment with digital signals within the cabin. Air travel is also converting to digitalization, moving from atoms to electrons, replacing matter with digital information in the microcosm of an airplane cabin, replacing dozens of control cables and hydraulic circuits with simple electric wires connected to sensor and actuator, make it possible to lighten the cabin by several hundred kilograms. Over the lifetime of a device, the saving in energy and CO2 emissions are considerable.
We are now coming to the end of our interview. Do you have a word of conclusion?
I would say aviation is expected to become decarbonized by 2050. Several possible technical and technological solutions are currently being studied. The fly-by-wire numerical control has undoubtedly been the main revolution of the last 20 years. Inaugurated by Airbus before being adopted by Boeing, it broke the taboo of direct control that ties pilot hands to control surfaces by replacing them with digital controls. It is now the new standard in modern aircraft design. The digital path will become more and more important in the total added value of airplanes and helicopters by producing considerable saving in energy and CO2 emission. Creating a hydrogen plane isn't the bigger challenge, rather it's the other ones along that can be difficult to place, like setting up the ecosystem needed to power airports with hydrogen. It would be necessary to refuel these new planes and above all to ensure the proper production of this hydrogen. At present, it will be difficult to supply the airline industry with green hydrogen in large quantities, confirmed the Flight Zero program. As an aside, Mr. Mehan Ibrahimi, professor in the Department of Management and Technology of the ESG of UQAM in Canada, following work comparing the greenhouse gas emissions generated by the aeronautical industry and those produced by the technology sectors, it appeared that while civil aviation is responsible for 2% of the planet's carbon emissions, information technologies are responsible for 4 to 5% of the total emissions. A sobering statistic.
Thank you for your time today. Could you remind us how to find you on social networks?
Yes, you can find us on the Facebook, LinkedIn, Instagram platforms and on our website www.leclercconsultinggroup.com. And I remind you that the experts of Leclerc Consulting Group are available at all times to accompany you or advise you on your projects and your organizational strategies. Thank you.